All right, welcome to this explainer. Today, we're diving into the incredible mind, the absolutely groundbreaking discoveries, and the sheer resilience of theoretical physicist Stephen Hawking. We're talking about a guy whose physical body was confined to a wheelchair for most of his life, but whose mind, well, his mind literally roamed the absolute furthest edges of the cosmos. Let's get into it.
So, here's our roadmap for today. We'll be looking at the diagnosis that ignited genius, decoding black holes, bringing physics to the masses, voice of a generation, warnings for humanity's future, and finally, a cosmic legacy.
Part 1. The diagnosis that ignited genius. A catalyst for brilliance. Hawking's life was defined by a tragedy that paradoxically kind of propelled his entire career. Think about this. Back in 1959, at just 17 years old, he starts at University College, Oxford. And honestly, he found the work ridiculously easy. By 1962, he's moving on to graduate work at Cambridge. But then, 1963 hits. He's 21, and everything just comes to this shocking halt. He gets diagnosed with an early-onset, slow-progressing form of motor neuron disease, which we usually call ALS. And his doctors tell him he's only got 2 years to live. 2 years. Now, here's the wild part. Before that diagnosis, Hawking actually admitted he was, kind of bored with life. He just wasn't applying himself. But this grim prognosis, it shifted the entire paradigm for him. As he put it himself, the prospect of an early death made him realize life was really worth living. It lit this unstoppable fire under him to understand the universe before his time ran out. Okay, moving on to Section 2, decoding black holes, unlocking the universe's deepest mysteries. So with this intense, renewed focus, Hawking decides to just tackle the absolute biggest, most complex debates in modern physics. At the time, the physics world was basically split in half over how the universe was actually created. On one side, you've got the Big Bang theory, right? The universe expands, matter dilutes over time. On the other side, the steady state theory, which says new matter is constantly being created, so the universe's density basically stays the exact same. Well, Hawking took these concepts of space-time singularities, which Roger Penrose had been exploring for the center of black holes, and applied them to the entire universe. And he mathematically proved that if general relativity is correct, our universe absolutely had to have begun as a singularity. And this momentum led to his most famous, groundbreaking discovery. See, up until 1974, scientists firmly believed that nothing, I mean literally not even light, could ever escape a black hole once it went in. But Hawking, he takes Einstein's general relativity, merges it with quantum mechanics, and shows that black holes actually aren't entirely black. They emit radiation. We now call this, fittingly, Hawking radiation. And over vast cosmic amounts of time, this means black holes actually leak energy. They shrink, and eventually they completely evaporate. But here's where it gets really interesting. This massive discovery created a huge headache for physics. It's called the black hole information paradox. Think about it. If a black hole evaporates and just disappears, what happens to all the physical information about the stuff that fell into it in the first place? Because quantum mechanics explicitly says information can never be permanently lost. This paradox sparked decades of fierce debate. Hawking even made these famous scientific wagers with colleagues like Kip Thorne and John Preskill. And you know what I love about that? It just perfectly showcases his willingness to be publicly wrong and actually concede bets in his relentless pursuit of the absolute truth. Section 3. Bringing physics to the masses. The master of the universe. 237. Let that number sink in for a second. That staggering number represents the record-breaking consecutive weeks his book, A Brief History of Time, spent on the Sunday Times bestseller list. Published back in 1988, it became an absolute global phenomenon. It sold an estimated 9 million copies, and virtually overnight turned a theoretical physicist into an international superstar. How did he do it? Well, he masterfully used really accessible analogies instead of bogging everyday readers down in insane math. Take a look at this one. This is straight from his work, explaining his no-boundary universe proposal. People would constantly ask him, well, what happened before the Big Bang? And he'd explain that asking that is like asking what is north of the North Pole. The question literally doesn't make sense, because the very concept of time did not exist before the Big Bang, just like there's no physical direction north of the North Pole. It's just a brilliant example of his gift for absolute clarity. Which brings us to Section 4, Voice of a Generation. Technological adaptation and resilience. So as his mind was expanding further out into the cosmos, his physical boundaries here on Earth were collapsing.
When he first lost his speech after a tracheotomy in 1985, his communication was incredibly basic. He literally just raised his eyebrows to choose letters on spelling cards held by an assistant. From there, he transitioned to a computer program called the Equalizer, where he'd use a little hand switch to select words. But eventually, as he lost the use of his hands too, the tech had to adapt again. By 2005, he's using cheek muscle movements, picked up by an infrared sensor on his glasses, to control adaptive word-predicting software. It's just his technological adaptation turned this devastating physical disability into an unbelievable testament to human resilience. And I have to share this fascinating little detail about his personality. You know that iconic, robotic, American accented voice we all associate with him? That was actually generated by a piece of hardware from 1986. And as the years went on, even when much more natural, advanced voices became available, he famously refused to upgrade. He kept that original, distinct voice because, well, he said he preferred it. It had fundamentally become his identity to the whole world.
All right, Section 5, Warnings for Humanity's Future, Protecting the Next 1,000 Years. Having defied the odds and survived more than 50 years beyond his original 2-year prognosis, Hawking eventually turned that brilliant mind toward the actual survival of our own species. And he didn't sugarcoat things. He warned us about sudden nuclear war, the creation of genetically engineered viruses, and extreme climate change. Actually, he even theorized that Earth could eventually end up like Venus, 400 degrees and raining sulfuric acid, if we aren't incredibly careful. He also issued famous warnings about the rise of superintelligent, unaligned AI. Looking at all these existential threats, he strongly argued that humanity's really only long-term hope is to figure out spaceflight and successfully colonize other planets. Interestingly, though, while he supported searching for extraterrestrial life, he severely cautioned against us actually trying to make contact. He figured that if highly advanced aliens exist, they might be nomadic. They might just be roaming the galaxy looking to conquer and pillage planets like Earth for resources. He pointedly compared our potential fate to that of Native Americans when Columbus arrived, which, as he noted, didn't exactly turn out well for them.
And finally, Section 6, A Cosmic Legacy, Among the Greats.
Stephen Hawking passed away peacefully at his home in Cambridge in 2018, at the age of 76. Following a service of Thanksgiving, his ashes were interred at Westminster Abbey. And where exactly is he resting? Precisely between the graves of Sir Isaac Newton and Charles Darwin. I mean, he was literally laid to rest amongst the absolute greatest giants of science, completely cementing his permanent place in human history. And there's this really beautiful touch to it all. His memorial stone in the Abbey actually immortalizes his greatest discovery. It's inscribed right there with his elegant equation for the temperature of Hawking radiation. This one equation beautifully links general relativity, quantum mechanics, and thermodynamics, and it continues to guide theoretical physicists to this very day.
So that brings us to our final thought for this explainer. Knowing that his mind was able to transcend a completely locked-in body to unlock the absolute deepest secrets of the universe, we kind of have to ask ourselves something. If the universe truly has no boundaries, and severe physical limitations couldn't trap a mind like Stephen Hawking's, well, how far can our own focused curiosity take us? What boundaries are you ready to push in your own life? Thank you so much for exploring the incredible mind of Stephen Hawking with me today. Stay curious, keep learning, and I'll catch you in the next explainer.